Without the pantograph or the electric highway, the electric truck is a battery-powered vehicle with limited range.
Now, one of the biggest questions we've been asked about electric trucks is, well, how far can they go?
So let's take a look at the Tesla electric semi. How does it measure up? Can it truly revolutionize long-distance trucking and make it environmentally friendly? Alright, let's take a look. So here we are on Tesla's website where they list the most important specifications of the semi-truck. We have acceleration with a full permissible load to 60 miles per hour at 20 seconds. We have 60 miles per hour up a 5% grade. We have a 300 to 500 mile range. We have 4 independent motors on real axles as a powertrain, energy consumption, fuel savings, base price, blah blah blah. The most important thing seems to be missing.
The pantograph, the missing link.
Vehicles like semi-trucks are categorized as Class 8 vehicles, which are bound to a maximum weight of 36 tons by the Federal Highway Administration. This weight includes the weight of the truck and payload, so any increase in truck weight will result in a decrease in payload, the part that pays the bills. For an energy source like batteries, which have a low energy density when compared to fossil fuels, this creates issues when attempting to create a vehicle that will offer a value proposition to the trucking industry. Let's assume our truck, without batteries, will weigh about 7 tons. This is based on current trucks without an engine. That leaves us 29 tons to play with to figure out how much of our weight to assign to batteries, and this is where designers need to make a decision. Include more batteries and the truck will have a greater range, but will be able to carry less payload. Or create a smaller battery pack, which sacrifices range for a greater payload.
There is a piece of the puzzle that is missing from the electric truck, and that is the electric highway. The pantograph that links the electric highway to the electric truck. And this is where the story starts to make sense.
And we want to be sure before we are going into the future with such a system. There were a lot of safety concerns in the beginning, so we had to discuss everything with fire brigade and police and so on. We have the voltage level of a tram, and the electromagnetic fields are lower than on a tram, so that isn't an issue. Overtaking is absolutely no problem. You just set the indicator or leave the lane, and the pantograph will automatically drop down immediately, and then you're free to go. So in that part, a battery or the combustion engine will take over, and you will have the full power without interruption.
One of the things that's really obvious sitting here is that the technology works. Like, we're running off grid power now, and it's really, really quiet in here.
With the pantograph, the electric truck has the range and the power required to transport over much longer distances. With the infrastructure of the electric highway, like rail transport, electric trucks become a viable option. With this infrastructure, in the future, in the age of robots, automation, this may become viable.
This winter. So down in Germany, there's a test track where we have been running this track for more than 1 year. Now we are satisfied with all those results, so we'd like to take it up and test the performance also on a public road. If you, for example, would like to overtake a vehicle, so you drive as a regular hybrid vehicle, take over the vehicle, go back in the lane, and connect automatically.
And now, so is it now?
Okay. I have the geofencing. I have the lane. It's must have it, and then you can drop this button.
Okay. So we see it going up there. Okay. There it is. Done. Connected.
Perfect.
Okay.
And now we drive electric.
Okay. And you can see it.
Charge the batteries.
And can you see it charging? It shows
yes,
you.
Yes, this is a charge. Das Ladebild.
10%. It's already gone up 1%.
Yes.
Okay. So, holding on.
Now Robert's going to step it up a level.
Powerfully.
Yeah, it is powerful. Yeah.
Follow me.
Yes, if you can.
Okay, so we're going 52 kilometers an hour, and we're now going to put on the gas. So as we turn out, pantograph comes automatically down. That's just built into the system. Very quickly passing Gregor, the other driver, and then we swerve back in when we're safe to do so. And so it's at this point you can only put the system back up manually, but you just push a button. That's simple. Simple as that.
Without the pantograph or the electric highway, the electric truck is a battery-powered vehicle with limited range. And for that, the calculations are true, however.
Welcome to our test facility.
Thank you very much. Okay. So this is part of the e-highway system.
It's actually the key component.
Okay.
Because this device, which we call the pantograph, the connecting device, that allows this truck to contact the contact wire while driving and providing the truck with electric energy. And that's basically the key innovation which we have in this system.
The pantograph automatically detects a contact line installed along a highway and connects to it. The catenary system, as it's called, is powered by substations put in along the route. When it's hooked up, it powers the truck and charges its battery as it moves. If the truck brakes, the energy generated can even feed back into the grid.
When you think of hybrid, you automatically think battery combustion, but that's not actually the case.
It doesn't have to. Hybrid is open to whatever type of hybrid you want.
So even as the technology advances, say in fuel cell technology,
yes,
this would still be a relevant
yes,
technology.
Because of your, the idea is basically that you can combine it with all these technologies.
The pantograph is the missing link that links the electric highway to the electric truck. And this is where the story starts to make sense.